Welcome back to the workshop How to Teach Science and Engineering, Lesson 4. My name is Sinha, Dr. Ranbir Sinha. Today we are going to talk about effective methodology of teaching science and engineering. You've seen in Lesson 1, 2, and 3 samples of how to teach. Let's try to formalize some of the things that we have learned in today's lesson. But let's first begin with how is effective methodology of teaching science and engineering different from the way you have been teaching? Let's ask some questions to ourselves, and you answer with yes and no, so that we can evaluate how you have been teaching. Question 1. Do you tell your students what you are going to teach today? When you go to the class, do you tell them what they are going to learn? Yes or no? Do you tell the students the applications of what you are going to teach, where it's going to be applied, so that they can visualize that if I learn this, I will be able to do this? Yes or no? Do you explain the concepts and how they relate to other topics or other subjects? When you're teaching, for example, a part of physics, modern physics, quantum mechanics, for example, do you tell how it relates to chemistry? Yes or no? Do you often show a piece of hardware? Do you walk in with a piece of hardware or an equipment into the class? Show it. Give a demo or a video before you start teaching the theory. Yes or no? Fill in these answers, please. Do you ask the students to solve a small and realistic problem in the class? When you teach some theory, do you ask them to calculate something based on that theory, so that they know how to apply it in solving a realistic problem? Do you explain the approach before deriving any formula? And after deriving the formula, do you plot the results? Do you show them how it behaves? Do you ask what if questions? What if we did it differently? Do you give the students time to absorb and think, or do you keep giving lecture? Do you ask a tricky or interesting question at the end of the class and ask the students to think about it? When they go back home, they have something in their mind, they're thinking about it. Do you ask such questions? Yes or no? Do you ask the students to read the lecture notes of the next class and come prepared with questions and doubts? Do you give them the class notes ahead of time? Do you update your lab classes to match with the theory that you teach? Do the lab experiments reflect what's being taught in the lecture classes? Do your students get any project or innovation ideas from the lectures? From the classroom lectures, they learn a lot of theories. Can they come up with an idea for innovation from those lectures or project? Do they think, okay, I can do a BTech project using these ideas because it's not been done? Or implement what they learn into creating a product? If you scored out of these 11 If you scored, let's say 10 yes or 8, even 8 yes, that means you are teaching the right way. You're using correct and effective methodology. If not, you should go through this course, implement some of the most important points into your teaching. Okay? If you're doing only 5 of these or less, then you really need to improve. You need to change your way of teaching so that what you teach is effective. Today we have a lot to cover because we are going to summarize whatever we have learned and formalize it so that you can actually implement some of them and find out which ones you are not implementing if you should implement. So we'll have to speed up. Communication skill is very important. Teachers have to be very good communicators. Okay. Communication skill for science and engineering teaching is somewhat different from teaching, say, history. We'll give you some examples and practice. Verbal communication. For a lecturer and teacher, it's extremely important to be a very good communicator. Your pronunciation of the technical terms have to be very correct. Always verify with a good dictionary whether what you are pronouncing is correct or not. I know a lot of teachers who cannot pronounce simple technical words, even the words of science, engineering, they cannot pronounce properly. They have learned from the wrong sources. It's not their fault, but they have to put an extra effort into improving their pronunciation. Okay? Your sentences that you use must be short, simple, clear, and grammatically correct. It's not always possible to check the grammar when you're speaking because verbal English is somewhat different and more flexible. For example, many rules in grammar books, you cannot start the sentence with but or and. But in verbal communication, it's allowed if it continues from the previous sentence. Okay? If you have set the context, you're allowed to use that. You can check the best speakers too. They use a sentence following a primary sentence where they start with and but. So it's flexible. Sentences should not be too long, obvious. Students get lost what you started with if your sentences are too long. Make them short, give them a pause. Give a pause after sentences. Fluency, grouping and blending of words. Important, very important. Pauses, because students need time to think. Pauses are very important. Accent, everyone has some accent, but try to make it somewhat neutral. If you're teaching in English, try to make it sound somewhat like more like proper English. Because students are going to follow you. They'll learn from you. If you have very strong accent, you can take my accent correction lessons. They are free. It's on YouTube. You have to speak slowly and smoothly. Do not speed up. Fluency does not mean speaking fast. Communication is the objective. It's not how fast you speak. Okay? Slow and smooth. Voice modulation is very important. There are some important words in a sentence. You have to pronounce them louder. It should not be boring. It should not be flat. Many teachers don't know that. They have not been trained. So I have some sample of how to read a passage. The same sample helps you Understand which words to emphasize. Technical terms, new terms, names of the scientists, those are very important. You can use your common sense to figure out these keywords I'm going to emphasize more than the other not so important words. Okay? Intonation, they all go together. Where you go up, where you go down in a sentence with your voice, that's important. Otherwise, it gets very boring, monotonous. Students fall asleep. Okay? So it's important. Written communication. When you write on the board, write very little text. Explain more using your speech. Draw figures. Whenever you are describing something, start drawing some figure. Simple figures. Plots are very important. Sketches and figures should be simple but clear. Practice it. Before you go to lecture class, practice. This is the only sketch I'm going to show, but describe it very well. Point to what you are talking about. Otherwise, students just look at your face. They don't know which part you are talking about. Point to that part. It's very important. It comes from practice. I can give you some examples later. Body language. All these are related. Body language. Try to dress nicely. Okay? That creates a good impression. There are lots of examples on YouTube. You'll find people talking about if you don't dress properly, you don't look proper. Students start focusing on those negative points. Some students, and they don't listen to what you have to teach. A pleasant smile is important. Not big laughs, but pleasant smile. At the same time, be serious. This is a tricky thing. How serious should you be? Serious enough so that students don't take it too casually. Okay? Show excitement about what you are teaching. Tell them why it's so important. Show in your expressions that what you are teaching is extremely important for them, for everybody. Okay? Moderate movement is important. Don't stand at one place, too stiff. Move around. Walk up to the board when you are doing something. Point to exactly what you are talking about on the sketch. Look at the students every now and then. Ask them questions. These things are important. Look at them. Okay? Moderate movement. When you're describing something, suppose you're talking about a body, do not just say, let us consider a body. Draw the picture or show with hands. Hand movement is also important, not too much. That gets distracting. Integrate all of the above. We categorize too many things, your pronunciation, this, that. But all these things belong together. All of them together form the communication skill. Okay? What you speak must match with what you're writing on the board or pointing at. You point to something, and this is what I'm talking about. Suppose you're drawing some picture, describe which part you are drawing. And what you are saying at the same time should match with what you are doing. This obvious, common sense, but many people do not know this. They start talking too much instead of drawing. Okay? Interaction. You have to write down on your class notes, okay, on your lecture notes, what questions you are going to ask to keep them interested in the subject. When are you going to ask? After describing something? Before describing something? I like to ask before describing something, before telling them how it's done, to make them interested, make them think. Do not spoon feed. The book has all that information. You need to make them think a little bit ahead of time. Then, if they are wrong, you can discuss, appreciate if somebody is right. Do not say you are wrong. Don't be negative. So let's look at it this way. Then you go on to describing what you know, the truth as much as you know. What problems to assign is very important. The problems in the classroom should be short, should use correct numbers. Whenever you derive something, explain to them with plots and charts what it should roughly look like. Assign them a short problem that they can solve in maybe 2 minutes. Ask them to look at the answer and see if it makes sense. Then assign longer homework that takes them step by step through the process of solving a more realistic problem. It can be somewhat complex. Don't make them too simple. Do not assign too many homework problems. Just 1 or 2. They have other subjects to study too. Do not burden them. Make them interested. Step by step, they should be able to solve the problem and understand whatever you taught. They need time to grasp by doing it, by solving it. Okay? Drawing attention of the students to whatever you're teaching and holding their interest is very difficult. For most of the students, about 60 or 70% of the students, science and engineering could be very hard. They get bored, they get frustrated, they are not understanding something, they lose interest. How do you hold it? That's part of the communication skill, using all of that. Very good and powerful voice, modulation, correct pronunciation, short stories, what-if questions, making them do the work, analyzing the answer and saying, does that make sense? Maybe it's wrong. Relate it to things that they already know, already have seen, their experiences. Do not create too many hypothetical problems, okay? Stay with reality. They'll show interest in what you're teaching. Okay? These are the main points of communication skill. I have separate lessons on just communication skill. Go through them. It's really going to help you. Summary, the main points we have learned in these 4 lessons, the first 3 lessons and here. Class lecture, let's say for 1 hour class lecture. You have to prepare for 10 hours, at least 10 hours. If you're new, this is a new subject for you that you are teaching, you may have to spend 30 hours preparing for 1 hour lecture. The great professors, they spend 70 hours. Okay? At least 10 hours. Even if you have taught the course before, you've got to update it so that when you go to the class, it becomes an impressive lecture. Okay? So you have to prepare, rehearse for 10 hours. Update the material also. Okay? What materials? Textbook. Give them the reference, but you need textbook to refer to. Don't start creating everything on your own. Stay with the textbook as much as possible. Some extra references, not too many. For every subject, there are 50 books. There's no way you can learn all of them. Okay? 1 or 2 references. 1 textbook, 1 or 2 references. For each chapter, maybe 1 separate reference or 2. Online information is very good. Okay? Sometimes textbooks have mistakes. You can figure that out from online information by double checking. As I did in the first lecture, the shape of the earth, I calculated. I didn't follow the regular textbooks that you see. I questioned them. Okay, lecture notes. You have to prepare very good lecture notes with details. What you write on the board is going to be much smaller. But your lecture notes should have little notes for you. What you're going to say should be written down. Otherwise, you'll forget. Okay? Ask students to bring calculator. You bring one too. Set an example. In your lecture notes, you should have some pictures. You can bring some extra pictures too, printed out pictures. You can bring some videos to show, very short videos. Bring a piece of hardware with you. Suppose you're talking about capacitor. You start teaching about capacitor and they don't know what capacitor looks like. That doesn't make sense. You should bring a little piece of capacitor and ask them something simple. In physics, you have learned that 2 parallel plates separated by a distance act as capacitor. But here is a real capacitor that looks like cylinder. Why? Ask them that question. Let them think. I've asked these questions to many experts. They don't know why. Okay? Find out the reason. Okay, I'll tell you. 2 parallel plates will take a lot of space. So some genius came up with the idea that what if I roll them into a little cylinder, then put it in a cylindrical cover? That became the capacitor, saved a lot of space. Okay? There are other kinds of capacitor too. Some look like small tablet. Diodes. When you're teaching about diodes, a real diode is not a triangle with a vertical line. They should know what diode really looks like, excites them. Show them, glow the diode, let's say LED, in the class. Then start teaching the theory. Do some easy experiment in the lecture class. Very simple experiment in the class, okay? That excites them. Then they are interested in learning the theory that you are teaching. Once they have seen something, they want to know how it works, okay? Then general flow of a class lecture, okay? This is how you prepare a typical class lecture, okay? These are the things you should bring, your class notes, the notes you're going to teach from, the textbook, calculator, some hardware, etc. Now, general flow of a class lecture. Beginning, it has to be a very impactful beginning, so the students are awake. They are interested and excited about learning what you're going to teach, okay? 3 to 5 minutes, very short. Interesting question. You can ask with an interesting question. You can tell a short story about how something was invented by an accident maybe, or by thinking. Story of a scientist. Review. If it's a series of lectures, which usually is in a class, you can review very shortly in few lines what they have studied earlier, what they have learned earlier, so that they remember, okay, now we know. Yes, that's clear now. We are going to continue with the same concept, okay? Objective of today's class. First you tell, for example, one of these things. Then say, today we are going to learn how to solve this problem. Or we'll see how this scientist did that. Review will continue further investigation, etc. Tell them what they are going to learn ahead of time so they know what to expect from this class. You can also tell them how it's going to benefit them by telling the application. Then comes the body, the main part that you are planning to teach today. The concepts. Concepts are very important in science and engineering. Concepts have to be clear. Formulation, how you formulate a problem. Approach of derivation. How would you solve this problem? Ask the students. Okay, we have formulated this problem. This is roughly what we are trying to achieve. This will be our goal, to find a relation between this and that. How would you do that? Let them think. Based on their previous knowledge, they may already know. Even if they don't know, you are going to derive it. But first tell them the approach, that this is how we are going to derive it. Then do the details. Most likely it's in the book too. But tell them the approach. The books normally don't tell them the approach. So you have to tell them. Assumptions, what assumptions you're making. Okay, you cannot consider everything in the world to solve a simple problem. So tell them, for example, we are going to ignore the friction. Okay, we are going to ignore the higher order terms. Results. Once you get the results, you have to assign them some problem to solve, and you get some resolved. You have to interpret the results. Okay, that's very important. What does it mean? Finally, you got a number or an equation. What does it mean? Interpretation is very important. In-class problem solving, as I said, let them do it right there. Don't solve all the problems yourself on the board. Let them do it. Then you solve the same problem. Then they understand where they made mistakes or how your method may be better. Who knows? One of the great students may be able to do exactly the way you are planning to do, or even better. It has happened to me. A girl student, we had assigned some very complicated numerical methods problem. A girl student did it analytically in one page. I gave her an A, okay? Because she taught me something that wasn't done before. It happens. Applications, extremely important. That's why I put it in red. In science and engineering, if you tell them the application where some theory is going to be applied, for example, we have talked about electrostatics, and positive, negative charges, they attract each other. Where is it used? What can we make? Laser printer. Everybody knows about laser printer and photocopier nowadays. Do you know how it works? How the color, black, magenta, and all these colors, how do they go to a particular spot? Electrostatic charge. Tell them to read about it, or you describe it to them. They will be so excited. You can tell ahead of time. What we are going to be learning today is going to be used, or it is used, in laser printer and photocopiers. I'll say, really? They'll be excited. Limitations of the theory. You have to tell them where to apply, where not to apply. If you apply, what can go wrong, okay? Relation to other topics and subjects, which I have talked before. Whatever you teach is not isolated. It's definitely a part of a much larger theory, a much larger context. You have to tell them how it fits in with the other things, okay? You can draw similarities, for example, while teaching potential difference. You can talk about the gravitational potential when teaching electrical potential and show the similarities. When you're talking about, say, resonance in an electric circuit, you talk about the mechanical equivalent of that, which they have probably already learned in first year, okay? All right, lab work. You tell them that in the lab, we are going to do an experiment to verify if the theory we derived here is correct or not, or maybe even extend it in lab, okay? After you have taught all that, highlighted what they must remember, the essential part, the concept, gone over that, you have to summarize this part. We are coming to an end, coming to the end of the class. Summary of all that details. How can you make it short? Summarize. This is what you have learned. This is where it's applied. Takeaway statement. If you can come up with 1 or 2 lines that they would remember and have an impact on their mind, the entire class, whatever they have learned today, if you can give them a statement that they'll not forget. I remember statements made by some of the professors 30 or 40 years ago. I don't remember the details of derivation, which I can look up at a book, but the concept is summarized in the statement. For example, one top professor, top in his field, he was #1 in the world, he said, to an infrared radiation, a black and white paint is the same. Think about it. Did you know that? I have not heard such simple statements from anybody else. I still remember that. To regular visible light, white and black are different. One absorbs most of the light, one reflects most of the light. But to infrared radiation, this black and white distinction doesn't exist. They absorb about the same amount, okay, of infrared radiation. I still remember that was 35 years ago. Assignments, give some assignments towards the end, homework. In-class problem is already solved. They understand much of it. This is more details. This is important. Don't give too many, just 1 or 2 to make the entire process of solving the problem clear to them. Hints. If it's a difficult problem, give them some hints that you may have to consider that too. Okay, let them do it. Do not spoon feed. Demo. Demo could be done even before, in the beginning, to get the class, get the students excited. Video, show a video of where it's going to be used, or show a piece of hardware, do a tiny little experiment right in the beginning, or at the end, or somewhere where you feel appropriate. But that's an essential part of a classroom lecture. Question and answer. Very quickly, answer some important questions if they have, or if they have come prepared with some questions for this class, that's even better. If they come prepared, or they may have questions here. You could ask them to interrupt you and ask doubts in between too during your lecture. That slows you down. I'm not absolutely sure at what point you can say, yeah, you can ask me any question anytime. Or you want to go through the entire part, ask them to write down the questions they have asked at the end. I normally prefer answering them at the end. Okay? Difference. How is this kind of teaching different from regular teaching that many lecturers and professors do? Okay. Application and purpose first. You really should talk about where it's going to be used so that they know that, okay, if I learn this, I can create this. Purpose. Theory later. Application first, theory later. Do not start teaching some theory and they have no idea why they are learning it. Many students ask, why am I learning so many things? Even for a mathematics teacher, they should find out practical application. When they're teaching about, say, matrices, they should know where matrices are used by engineers and scientists. And tell them that if you learn matrices, for example, all the animation of the computer, things changing, moving, and all that, it's all matrices. Okay? So they should learn matrices if they want to do any computer graphics. Theory later, an extension of the theory at the end. You cannot teach everything in 1 hour. Now tell them that, this theory has been extended, which you will not learn in this class, but maybe in the next semester when you have finished the basics. Okay? And how that extension helps. Okay? For example, when you talk about Newtonian mechanics, you can tell them ahead of time. And okay, they are extensions of Newtonian mechanics by Lagrange and Hamilton. They have certain advantages. The formulation. Okay, now you can even give an example where Newton's method doesn't really work very well or gets too complicated. Okay, drawing plots and figures. This part I find is the most important part in science and engineering teaching. Drawing pictures and figures, plots is very important so that it becomes easy to hold it in the mind. For example, one professor, one of the best professors I've ever had, he told me that to optimize the path of the aircraft, suppose it's got to go from here to there, that height. It's not a straight line. It goes through that and then goes up for many jet planes, for example. It was counterintuitive. I thought straight line would be the best one. Then he showed it to me through mathematics and by plotting. I remember the plot. It goes down, it goes up, then goes down a little bit, picks up speed, and then reaches that point. That's the time-wise shortest. Okay? Easy to visualize, grasp, and remember. All these complicated formulas they will not remember. They should know what it means and what terms are involved. The exact relation they can always look up. But if you plot it, how it behaves. For example, if you're talking about hyperbolic tangent or some term that involves hyperbolic tangent, what does the final plot look like? Okay, quadratic equation. Very difficult to remember. If you plot, they'll remember. Okay, that's what the plot looks like. That's how it varies. Okay, good. Thinking, make them think in the class. Simple questions, ask them. Do not just spoon feed and tell everything. Ask them to think. Let them explore. Give them some realistic problems to solve in the class so that everything gets clarified in their mind. Okay? Encourage them to come up with projects and innovative products. Okay. One can say everything has already been done. Yes, somebody has done it. Yeah. But you can always modify it. You can make it better. People say everything is done. No. Those people will not do anything useful in their lives. The reason we are teaching them because they become creative problem solvers. They come up with new ideas, not everything is done. We know only 4% of what's there to know. Every year, thousands of new products come up with slight change. For example, shoes are still being redesigned and modified. Better materials being used, better comfort, more reliable. Okay? Things are changing. There are millions of things that can be done from what they learn. Encourage them to come up with little projects based on that. Okay? This is how it's different from the way many teachers teach. Okay, implement these things, please. I'm giving a pause so that you can have a quick look at that. Okay? All right, extra tips. This is important. How to become a great science teacher, science or engineering a teacher. Believe that what you are teaching today is extremely important. Do not show up casually as if it's a boring job you have to teach, so you're doing it just because in the textbook and syllabus. No. Do extra preparation to find out why it's important. Then convince yourself that, yes, it is really important. They should understand this. Someday they're going to need it. Every time, every class, believe in whatever you are teaching. Believe that it's extremely important. Therefore, tell the purpose and teach enthusiastically. You have to be enthusiastic. You have to show that, yes, it is important. It should show on your facial expression Do not make it boring. Okay, we are going to learn about laws of thermodynamics. There's zeroth law, first law, second law. No. Show excitement. Zeroth law. What is zeroth law? Why not first? Why is it called zeroth law? Ask them. Do we start things with zero? You'll get all kinds of answers. Some of them are just extraordinary. One student told me, oh, because in computers, quite often we start with zero. In those days, there were no computers, okay? It was added later. First law, second law, third laws were written down, discovered and written down, tested. Then there was a very fundamental law that came up and said, oh, we forgot that. So we have to put it in the beginning, but instead of changing these first three numbers, they made it zeroth. Starts with zero, zeroth law, okay? That gets them excited. Teach enthusiastically, whatever you say, whatever you draw, as if it's very important. What is that? Be active in the class. It's your class. You're giving all your knowledge to them in a short time, making these young people think about it and wonder, and maybe come up with something new. Be active and act active. Okay, don't stand at a place. Act active. Sometimes it's hard, I know, to be active all the time. You have to practice acting active. Improve your communication skill. There are separate lessons I have given. This is so important, and teachers are not given. Some naturally have very good communication skills, some don't. But everybody can be trained to reach a level of communication skill, acquire that skill, to become very good teachers, because it's extremely important for the teachers, okay? Entire communication skill. Speech, speak clearly, slowly, drawing the diagrams correctly, simple diagrams that makes it very clear to the students. You do not have to spend half an hour drawing a very nice bolt, okay? It was a waste of time. There was a time drawing a screw and a bolt was the ultimate of engineering. Those days are gone. Now they have to learn very quickly about the screws and bolts, the formulas, what they relate, just the concept. You don't want to spend 10 minutes drawing a very nice bolt for engineers, okay? Very quickly draw something symbolic, tell them roughly what it is, and go on to deriving the formula very quickly. So this is how it behaves, because it's possible that in their entire life they will not design a bolt. They should know what it is, what can go wrong, how to modify it if necessary, okay? Text, very little text. They all should coordinate with each other, okay? These two are very important. Write few words. Body language. BL is for body language. Gentle smile, excitement in the eyes, looking at the students. That's very important, okay? At the same time, don't get too hyper, start moving your hands too much, okay? Just a little bit, slow, gentle, because if you move too much, they get distracted. They'll start looking at how you're moving instead of listening to you. They have to look at the picture, listen to what you're saying, watch your hand movement, and interpret all of them together. So it's difficult if you're overdoing your hand movement. Special lesson on communication skill. I have 3-4 lessons on communication skill for teachers. I'll create one more, just one more to summarize, okay? All right. A focus on the average students. Many teachers talk at a level as if they are teaching PhD students. No, come on. You were on the other side once. How difficult was it for you to understand these complicated concepts? Focus on the average students. The best students will learn on their own without you too. I can guarantee that. Some students, a few students are very weak. You may have to spend extra time for them. Some tutorial hours or something. But focus on the majority. That's about the 80% of the students who are not understanding now. Focus on them. So speak slowly, clearly. Make sure they understand what you are teaching. Give pauses after everything you say. They need time to think about what they said. Make them think along with you. So what do you think this is going to do? If you don't ask any questions, they're just going to listen. Passive listeners they'll become. Okay? They'll not understand, they'll not participate, they'll not be able to interpret it and apply it. Make them think. That is the biggest challenge. How to make the students think almost the way you think. Okay? All right. If a student has a doubt about something you said or wrote, clarify slowly using a different kind of diagram, different kind of explanation with similarities with something they already know. Analogy. Okay? Do not keep repeating the same explanation again. It doesn't get better. Okay? If they have not understood one way, make it simpler, slower, with examples, with exact numbers maybe. Okay? All right. You can do it. You can do it. Explain the exact meaning of technical terms. Some technical terms are thrown at us. Simple things like phenomenon at 6th grade. Nobody tells them what a phenomenon is. Plural phenomena looks like something scary. Tell them what it is. It's an event. It's a thing that happens. Simple words. Okay? Or suppose you say something like, let's say, semiconductor. Tell them semi means partial. Conductor, probably you have taught earlier. They already relate. Okay, so it's not full conductor. Okay? It's very simple. Technical terms. Also the meaning in the simple language. If you have to use local language, use that, because sometimes these English words can be very intimidating. Okay, big, complicated names. For example, let's say eigenvalue. People start teaching, we are going to learn about eigenvalue. This is how you do it. What is eigenvalue? Value, everybody understands. Okay, what's eigenvalue? Because it's taken from a German word. Eigen means own, inherent. Okay, own value. Something is given its own value. Then it starts making sense. Okay, here's this matrix, this. And that's the eigenvalues, own value. Okay, so it makes sense, much more sense, instead of just throwing these words that sound very foreign. Convolution theorem. Convolution theorem. Convolution. Do they know the meaning of convolution, this word? Explained in English, maybe in local language. What does that mean? Then they'll retain. Complex. Okay? Not straightforward. Not straight. Convoluted. Crooked. Complex. Okay? Electric potential. What's potential? This should very difficult to explain. Potential. It's like possible amount of energy, possible amount of work it can do. Depending on where it is, depending on the position, how much it's capable of doing. It may or may not do it, but it's got that much of built-in inherent energy, potential energy, because it's here. Explain to them simply. Okay? For example, your potential. That means you are capable of achieving that. Whether you do it or not is different. Potential energy is similar. Okay? See how easy it becomes to remember later. Okay, this is the potential energy. That means how much is possible. Okay. Build and constantly upgrade your knowledge. Let me give you an example. A fairly well-known professor from an industry, 40 years of industry experience, came and taught a course on electronics to IIT students. And he failed nearly all the students and criticized they don't know anything. These are IITians. No, I don't understand this and that. And he didn't know that I'm an IITian too, meaning graduate a long time ago. Anyway, he was putting them down. I said, sir, this new adapters for charging the telephones, they're much lighter than the old ones and also don't get very hot. Can you tell me why? He started telling me all kinds of nonsense. Oh, suppose there's this transformer and that step-down transformer, and then it goes through 4 diodes, this, that, all kinds of things. He didn't know because he didn't upgrade his knowledge. He was still thinking about this old transformer and all that. And I said, have you heard of SMPS? Have you heard of semiconductor devices, power semiconductors? And I started showing him how it works. And he was surprised that I'm an aerospace engineer. I know about electronics, and he is from electronics. He didn't know that. Upgrade your knowledge constantly. Things are changing very fast. Fundamentals are extremely important. Also, the new things that are coming up. Be honest if you don't know something. Say, I don't know, I'll look it up. Understand it. Work very hard to understand. Correct your mistakes, and the students will respect you. This is very important. Don't give them nonsense. They are smart. They'll figure out, and they'll laugh at your back. Their respect for you would go down if you start talking nonsense. Upgrade your knowledge. Admit if you don't know something, so I'll have to look it up. Understand that part and go and explain it to them. Okay, spend extra time. Students will respect you. Copy the best teachers. I'm not the best. I know it. I'm a good teacher. I think my students understand. They can apply what they learn and create new things. I've done it many times. Still, there are teachers who are much better than me. Walter Lewin, for example, from MIT. Look at his videos, how he teaches. Copy some of them. You cannot copy everything he does, okay? Copy some of his styles, like doing a little experiment to get the students excited in the class, explaining very simply, writing very clearly, giving realistic examples, all that you can copy. And how active he is. Implement and improve. Implement some of those qualities of the best teachers and improve some of their styles. Be strict about discipline. This is something missing. Something missing. Discipline is the most important thing. Teach them. How? You be disciplined and you be strict about it. No, sorry, you have to do it. Homework. Do not say, okay, you can turn it in next week. No. This is the time. You have to do it as much as you can. You have to do it. And you'll be graded on that. Punctuality. They have to turn in things on time. They have to come to the class in time. Okay. Grading. Try to automate as much as possible. Okay. Grading takes a long time. Give the questions such a way that it's almost automated grading. And then there's an advantage. You can say, sorry, the computer program is being fair to everybody. No exceptions for you. Okay. You don't get the blame. Be approachable and empathetic. This is how it's pronounced. To the correct extent. Be somewhat friendly. Also strict. In some cultures, people respect everybody. In some cultures, once you become too friendly, they stop respecting you, take you for granted. It happens, okay? So depending on the culture, you have to be strict enough, okay? But at the same time, don't be dictatorial. Don't show that you're some big shot. You don't want to talk to them. Let them talk. Listen to them, okay? To a limit. You set your own limit. Be a guide, not a boss, okay? Be a guide. You're creating futures. Their future, future of the entire humanity. Be a guide. Guide them to the best of your ability. Remember, they should learn professionalism by copying you. So you act professional. Don't show up in shabby clothes, uninterested, burden. Does not matter what's happening in your private life. other problems in the class. Be a role model, positive role model. You think I have no problems? I have hundreds of problems. I actually face them bravely. Okay, face them. But I don't mix up those problems with the class. Be positive. Harder the problem, better it is for me. Okay. Positive role model. Good. And there's one thing I would request you, never put down any student. One of these students can be much better than you. How would you feel? You don't know how they feel when you put them down. No, you're wrong, and that's wrong, this, that, or shouting at them. You have no idea how they feel. It can be very dangerous. Okay, good. Hands-on practice. This is what you have to do. I don't spoon feed, sorry. And you don't deserve to be spoon-fed because you're grown up. You're taking up the biggest job in the world, creating the future. So you do your part. Hands-on practice. Select a topic that you like to teach. For example, you could be an expert in numerical methods. Pick a topic. Use the methods suggested in this course to prepare a lecture, a sample lecture, to the best of your ability. Follow these instructions and apply as many as possible these points I have mentioned. Remember to include the points that you do not normally use that are here and think about them. If they seem reasonable, yes, I could improve by using this point. Improve it. For example, asking questions. Some teachers just give lectures. Everybody likes to give lectures. Asking questions. You have to ask questions. Maybe every 3 or 4 minutes you have to ask questions to the students. Yes. Nobody is impressive enough to hold their attention for longer than 15, 20 minutes. You have to keep them engaged by asking questions. Point to some people and say, how would you do it? In the beginning, they may feel uncomfortable. They'll get used to it. So in your preparation, ask some questions. I'll try to answer your questions, okay? See the previous slides for all these points. Rehearse many times. Rehearse. Modify it. So no, this part, I'm going on and on for too long. It's not very important. Let me cut that down. Add this part of explanation. Okay, modify, loop. The flow may not be right. Okay, you're jumping from one part to the other. Put something in between. Modify. A loop. Just modify, rehearse, modify, rehearse. Make a presentation probably to a friend of yours, if possible. And then this is the most important. Are you happy with what you're going to say? What are you going to present in the lecture? Okay, make that. And make the presentation. It should be like a classroom lecture, okay? Get it recorded, video recorded by a friend. Okay, maybe 2 or 3 of you can work together. One does the presentation, another records, and then switch the role. On the 3rd day of workshop, maybe turn it in by tomorrow, okay? We'll evaluate that and give you suggestions for improvement. The best teacher, best among you, gets a surprise. Okay, will you do it? By tomorrow, turn it in, please. To do, let us build a world where every child has the opportunity to gain knowledge. Not only memorize things, gain real knowledge. And has the freedom to explore, think, and create. Let them explore things. Let them do some small experiments. Let them think, understand, and create new things with that, with their creativity. Start it today with this lecture. Thank you. If you have any questions, I'll take. You can put them in the comment section. Thank you very much.